This is the 10th lecture in the FOA series of lectures on premises cabling. In this lecture, we'll be talking about wireless and its place in premises networks. Wireless uses radio frequency transmission to connect directly to the user device, which is in effect simply replacing patch cords. Wireless is preferred for mobility. It allows the user to roam unencumbered by cabling within the service area. Wireless is preferred by users of many devices today, including laptops, tablets, and even Wi-Fi is used for cell phones within a premises to provide mobility. Many types of devices can use wireless networks. Mostly we think of laptops and tablets on an Ethernet network, but they can also support voice over IP telephones, IP video for surveillance systems, security systems, and anything else that will run on normal IP or Internet networks. Wireless networks are used just about everywhere, not just in your local coffee shop, but in offices, homes, campuses, auditoriums, libraries, public buildings, hotels, all the shops and restaurants, warehouses, almost anywhere where users need to connect to a network and want mobility. When we're talking about wireless and premises networks, we're generally talking about Wi-Fi, the acronym that's used for a system called Wireless Fidelity that covers all 802.11 standards from the IEEE. Currently, Wi-Fi is used in most offices, commercial hotspots, municipal networks, and homes. And anywhere else, mobile connections for wireless are expected. Wireless, of course, is not totally wireless. When it fits into a typical structured cabling network, the wireless access point is connected on either copper cabling, UTP, or on fiber, and the wireless part is really the connection to the device being used, like a laptop or a tablet or a voice over IP phone. So the wireless part is only the replacement of the patch cord. Access points are the gateways to the wireless network. The access points are connected to the network on cabling and have a wireless range of up to about 300 feet indoors and 2,000 feet outdoors. But the bandwidth is distance dependent, so it's better to be closer to the access point than farther away. Another way to look at a wireless access point is it's very similar to zone cabling in a normal copper structured cabling network, where instead of a consolidation point that goes out to the desktop, we have a wireless access point that goes out to a wireless device, and the wireless link replaces the standard patch cord. Access points can be mounted in the ceiling, on a wall, on modular furniture, or even placed on a desktop, any place that's convenient. When designing a wireless network, there are a lot of factors to consider. For example, the coverage, how much area may be covered by wireless, and how many access points will be required. How many users will be using the capacity of a single access point? Are there any sources of interference? How will the access point be connected into the cabling system, and how will power be supplied to it? And if there are any future use issues that may be considered. Planning for coverage, you need to define the area that the wireless system is expected to cover. Is it indoors or outdoors? Are there areas that will be isolated and not expected to get coverage from a given access point? The general rule is to allow for about 30% cell overlap from an access point. The capacity of the network is very important. How many users will be using an access point? A given 802.11n, the latest series of access points, can supply up to 100 megabits per second per frequency, or almost 600 megabits per second. But how many users could be connected at what time? What type of equipment are they using? What kind of applications? If they're doing email, they're going to be using a lot less bandwidth than if they're downloading video. You have to trade off range for data rates. Wireless networks can be disrupted by interference. The interference can come from other types of equipment or other wireless networks, reflections off various building features, or moving vehicles. It may require you need to site the antennas high or make them directive. When planning for access points, you need to understand what are the network constraints. Can the network handle additional traffic? Where will access points be cabled to? How will additional cabling be installed? What kind of cabling will be used? Remember that a typical 802.11n access point needs to have a switched 1 gigabit per second data connection in order to be effective. Access points also require power. If it's AC powered, it will need an uninterruptible power backup and data quality grounding. If it's using power over Ethernet, the access point must be within the limits of the power able to be delivered over the unshielded twisted pair cabling using power over Ethernet. Security is one of the major problems with wireless. Any access point can be an entry point for hackers, even those sitting in your lobby of your building. Passwords alone are inadequate. You need special wireless routers, and wireless may actually be on a separate backbone. Some companies have a backbone only for their own employees and another public backbone for visitors. The only way to properly design a wireless network is to do a site survey. You use test equipment with site survey tools and temporary antennas and access points. You measure the performance between access points. You identify sources of interference. You determine the level of coverage, and that way is the only way to determine access point locations. Once you determine the access point locations, you should have an adequate wireless network. More information on wireless networks and premises cabling can be found at the online reference guide of the Fiber Optic Association. Go to www.thefoa.org to get more information.